Hello and welcome to our today's heat session. My name is Mark Weimar, I'm Product Manager at PROBAT. Referring to energy, there's nothing new when I say that we are currently in a challenging situation. Rising costs of especially natural gas due to the scarcity and of course requirements regarding sustainability following the trend of decarbonization, so to get rid of the fossil fuels requires more or less rethinking of energy provision and of course its use. As the world leading supplier for coffee processing systems, PROBAT is going to meet these challenges with the development of innovative products. And therefore, we of course are able to implement alternative drives to our roasting systems. At our Connected Market Symposium in September this year, we have presented the first hydrogen-powered roaster, our beautiful PO5 hydrogen, and we would like now to give you a short view on the event and to show how the customers were able to get in touch with the roaster itself and of course to taste the coffee roasted on the hydrogen powered roaster. Enjoy! So further details on the PO5 hydrogen and of course the alternative drives for our shop roasters will be given by our colleagues in their pop-up session on December the 15th. When we now see the industrial sector, we received a huge response regarding hydrogen alternative drives from our customers, and of course they also want to convert to future technologies to be less independent or to be less dependent on natural gas. So as a part of this heat session, therefore, we would like to discuss the status of alternative drives for our roasting systems. And for this we will go into LPG as an interim solution, but also focus on hydrogen for the long-term solution in our point of view. So if you have any kind of questions, please feel free to put them in the chat and we will try to answer them during this session. So now I am pleased to welcome two highly competent colleagues from our R&D project team. So on the one hand side there's Thorsten Rensing, our burner specialist, and of course Peter Heinke, who is our process engineer, and together we will now go into every detail surrounding the alternative drives for our roasting system. So,
yes. Thank you, Mark.
Guys, let's get started.
Yes. Mark.
So I would like to start with LPG. Maybe we can answer some questions about that. So, Thorsten, can you just describe what is LPG and how can we use it as an energy source?
A good question. LPG is an acronym for liquefied petroleum gas. It is a side-by-side product of refining of petroleum and is a mixture of propane and butane in different ratios. And like natural gas, you can use it for every combustion you want in your roastery or in other industries.
So from the burning process itself, there's not really a difference between natural gas and LPG.
Yes, that's correct. You have to do some adjustments, but in general, the combustion is almost the same.
Okay, perfect. And are there any typical characteristics of LPG?
LPG is a liquid at room temperature and about 10 bar, so this is the great advantage of it. You can transport it very easily. And the heating value of it is almost twice as high as this of natural gas.
And from the customer perspective, when a customer is considering to plan the implementation of LPG, does he need to provide any special components?
Yes. First of all, the most important thing is a tank you need to on your roastery, and possibly you need a vaporizer. This depends on your needed capacity. After this, you need a pressure regulator and then the piping through to the gas control line.
And this is needed in case of a new installation, and of course, I guess so for a retrofit.
Yes, that's true.
Regarding the retrofit, are there any special requirements on the machine, on the roasting system?
Yes, you have to consider the whole roasting system, the age, the condition, and the installed components, and then you have to provide the same gas pressure as of natural gas. If your roastery is located in the European Union, you have to provide the DIN standard. And if you're outside Europe, we have to check it by a case-by-case basis.
So maybe regional standards.
Yes.
Okay.
Correctly.
So it's always an individual view needed on the roaster or the roasting system itself. There's not a one-fits-all solution.
That's correct.
Okay.
There are some points. If you have an old machine, like over 10 years old, you possibly need a new burner with new gas line. But if you have a newer roaster under 10 years, it may be possible that you just need some spare parts to change, so you can change and retrofit it quite easily.
Okay, perfect.
So am I right, Thorsten? So the main advantage of LPG is you can storage it. Yeah?
Yes.
And did I understand right? You can use it on your normal process, like when you have natural gas.
Yes.
And without big issues.
That's correct. And
perfect.
An advantage is you are independent of the natural gas pipelines.
Yeah, perfect.
And maybe for our customers, to make it clear, we can use it for the main burner, for the roaster, and of course for the heat treatment systems.
Yes, on all burners in your roasting system, main burner, after burner, there's no problem.
Okay, thank you very much. So I guess this was a rough introduction into LPG. I said before, we want to focus on hydrogen because from our point of view, this will be the future. And so I would like now to switch over to hydrogen as a clean, future-oriented alternative to natural gas. So I would like to start to give some details about hydrogen. So maybe we can jump over to the next slide. Thank you very much. So hydrogen is more or less the smallest and most common element in the universe, and we can find it almost exclusively in the bound form. So especially it is found in fossil raw materials such as natural gas or crude oil, and its name already indicated hydrogen, and the chemical symbol H2, the main sum or the main part of hydrogen is bounded in water. So on the screen we can see there a color spectrum of hydrogen. So how good hydrogen is for the climate protection depends mainly on its production or production method. So it has become common to clarify or to classify hydrogen types into colors. Here we can see several colors, several types, and behind that several production methods. So I would like to go into 3 of them. The first one is green hydrogen. So green hydrogen is produced from water using regenerative energies in an electrolysis process. So the electricity can be taken by photovoltaics or wind power, and so it is one input factor for the process. Then the water molecules are split into 2 elements. On the one hand side there's oxygen, and of course then hydrogen. Yeah, and if the electricity comes from renewable sources, then we are talking about a CO2 neutral process for the green hydrogen. So I guess green hydrogen is the future to really get rid of every fossil fuels. But the next one is gray hydrogen. This is actually the type that dominates the market. It is obtained from fossil fuels, so crude oil and coal, natural gas. And under heat, the natural gas is converted into hydrogen and carbon dioxide. And this is also the disadvantage, that we have a huge demand, huge volume of carbon dioxide that is more or less the part of this process. So when we are producing 1 ton of hydrogen, there is 10 tons carbon dioxide on the negative part of this process.
So it is like burning natural gas in the first place.
Yeah, exactly,
Okay.
exactly. So there is an improvement of gray hydrogen. This is called blue hydrogen there. This is almost the same process, but the CO2 does not goes into the atmosphere, so it is stored and captured. The process is called carbon capture and storage, or shortly CCS. And so in the balance, we can also state that blue hydrogen is CO2 neutral.
But you should prefer the green one if you want to be net zero. Or
Net zero is, I guess, the green one, the long-term solution, and of course, I guess the aim of
everything.
Customers. Okay, perfect. So maybe we can give, because I guess this would be interesting, the other colors. Maybe we can jump back to the overview.
Yeah, that would be my question as well.
Just to make it clear. So we have talked about the green hydrogen, the blue hydrogen, and the gray hydrogen. So just rough explanation about the other colors. So pink hydrogen is where the energy comes from the nuclear source. Then the white one is more or less a waste product from other chemical processes like fracking. The black and brown is the use of coal as single source. The yellow one is a mix of renewable energies and fossil fuels. And then the turquoise hydrogen is a pyrolysis of methane as a part of natural gas in hydrogen and of course solid carbon. Okay, so now I would like to go further to show the potential of hydrogen within a coffee roastery. So I will jump to the screen. So at the first stage, we have the purchase of electricity options. We have an own production or a grid feed, or maybe other power purchasing agreements. This all ends up in a process. As an example here is the electrolysis process, or you can also state alternative processes. This would be the production itself. Another option would be the direct delivery of hydrogen. Then on site there is a storage system where we can store hydrogen and be able to refuel it. And then we can use the hydrogen for several parts inside the roastery. So as we already said, it can be used of course for the roasting processes, so the main burner, heat treatment systems of course, but there's also a potential maybe for vehicle fleets, forklifts, etc., etc. So we can feed not only the roasted or roasting process, there are other points we can use hydrogen. So these are the basics. So let's talk about some characteristics of hydrogen. Maybe the point emissions is very important, I guess. So
Okay.
what is really the advantage or the advantages of hydrogen?
Yeah, the biggest advantage obviously is that the combustion does not produce any carbon dioxide. So if you have green hydrogen, then the roasting process does not produce any carbon dioxide from the combustion. So, and this makes easier, especially if you are based in Germany, to comply the TA Luft, the German Clean Air Act, and you can put your roastery net zero. And it's future-proof. As you already mentioned, Mark, hydrogen is the most common element in the world, so it is practically infinite. Hydrogen can be produced on site, so you are very self-sufficiency, you are completely independent on delivery. And a big other thing is that hydrogen has no influence on the taste of the coffee.
I guess this is the most relevant
Yes.
point of view.
Of course.
The coffee is also great from hydrogen roasting.
Yeah.
And then I guess a very important topic is safety. So when we had the symposium here in September, a lot of customers were asking about, is it safe to roast, to handle, or to process hydrogen? What is our answer about that?
First of all, you can say the use of hydrogen is safe. You can use it almost as all other fuel gases, so it's stored in a tank or in a container, and then you deliver it through your pipes to your roastery, so almost the same as other gases. But you have to consider the customer has to consider some things. So since you can't smell hydrogen, you have to check the gas control light once a month with a leak detection spray. And the leakage rate is slightly higher than of natural gas, but it's still far below the limit of that dangerous environment can arises. Nevertheless, you should consider a good ventilation of your gas pipeline, but it's all the same as of natural gas. And of the safety systems in our roastery, I can say that Peter can tell some things.
Transfer to the roasting system. Of course, in general, for new plants or for new roasters, we doesn't depend on the burner type. We support the regulations, the actual regulations, and therefore all the safety stuff that contains in the regulation. But what is special to hydrogen? Hydrogen special is what you need to do is nitrogen flushing. That means before and after ignition the burner or firing the burner, you need to purge the gas pipe to the burner. That means that depends on that is according to the Wobbe index of the hydrogen gas, and but in general the the regulations are, they are fulfilled also for this burn type.
So the flushing does not take place after every batch. So once you burn out,
right. At the I would say in the morning when you start the roaster, you start the burner, and then it's purging the before igniting the burner. It purges
and then
the
batch.
and then batch. Right.
In the evening, maybe.
Yes. Then when you stop roasting and the roaster is going down, and then the burner is stopped, then it there is also an purging phase after burning because because of the Wobber index. That is that needs not so much oxygen for that. But also for retrofits, I guess that is also a topic. You can easily retrofit your existing natural gas burner, for example, to a hydrogen burner. So that is actually not a big deal. You have to take an
Do I need a new burner or?
Yeah, actually you need a new burner with a new gas train. That is due to the characteristic of hydrogen and the heat value of hydrogen. And but the process itself is the same like on natural gas. And and also the safety components are the same, and
so
it's covered by the regulations.
We said before regarding the LPG solution.
Yes.
So is this the same here in case of a retrofit? So our recommendation is generally if the customer is going to consider using hydrogen, using LPG, that we have a view on the roasting system, and of course to bring it to the state-of-the-art technology. This is our recommendation.
Yes, Mark. We need an individual view on the roaster, and they're all different and
of course,
different ages. The roaster, but that's right.
Okay, so let's go on to the burner itself. Are there special operating modes available? I'm thinking about some kind of hybrid operation mode.
Yeah, what is I would say everything is possible. So you can run the roaster and the burner with 100% hydrogen. That's okay. But you can also run, in case of, for example, dual fuel burners, that is possible. You can run with 100% natural gas. And according to your demands, for example, if you can switch between from 100% hydrogen to 100% natural gas, or a slide
in between
20% hydrogen and 80% natural gas, and so on. That gives you the advantage that, for example, you can roast 1 or 2 batch and to prevent your green fingerprint, for example, or maybe you need to take the hydrogen consumption, and you can use hydrogen and natural gas as you want to.
And if I want to upgrade if a customer wants to upgrade a roaster now, but just get hydrogen in 5 years, is it also possible to start with natural gas, and then after 5 years, now I have hydrogen, and let's start roasting on hydrogen
without changing the burner?
Yes. And do the customer needs to know it to say it to us if we want to do this?
Yeah. So, for example, if he knows exactly that he's using hydrogen, then he can. I would prefer a dual fuel burners, so you can use natural gas and then hydrogen if you want to. And what you also can do is, but that is something you need to know now, or at the moment you install the burner. That is a special kind of burner that can use hydrogen, but also can natural gas. So that is no problem. You can use natural gas with a burner and switch to hydrogen, but we need to know it before to select the burner, the right burner.
Okay, sounds very good.
Yeah.
So we have one last topic regarding the comparison from natural gas to hydrogen, and especially for the hydrogen supply. But before, I just see that there is a question from Enrico. So we just mentioned there's no CO2 produced during the burning process of hydrogen. What about NOx? Do we have there any answer for him?
Generally, you can say that the NOx is slightly higher than of natural gas, but we do not have measured it. So you can say it's slightly higher, but not as high as somebody thinks.
Okay. There's one additional question from Enrico, who is asking about the production the provision of hydrogen, and in this regard the electric energy which is needed for the production. I guess this is not a topic for us. I guess this would be then a topic for a gas supplier or similar. I guess we just focus on the burner technology and the roasting technology.
Yes.
Right.
So Enrico, please contact your regional dealer for gas supply, and maybe he can answer your questions. Okay, then I would like to switch over to the next slide. I guess this is very interesting for our customers, because here we can see how many batches can be roasted with hydrogen. And we have here presented the PX120, the Neptune 1000, and of course a higher industrial machine, the Jupiter 4000. And in contrast that, there we have two possibilities, two options to provide the hydrogen. One is the cylinder bundle, in this case 9 cylinders, and the other option is a container system, the 45 feet. Maybe we can talk about that and give a little impression of ourselves, how we can handle the process of roasting regarding these figures.
Yes, what you see is a cylinder bundle with 9 cylinders. That is a common size, I would say, for cylinder bundles. And the container is a common size for a container. But, what you can see here is just to be sure that you be clear, if you have, for example, a Jupiter 4000 with a higher capacity, or maybe 2 or 3 rows running, then you can see here it's 7 batch in the case of a cylinder bundle, and 130 batch in case of a container. That is recommended to. Maybe it's possible to get a pipeline with hydrogen, in case for a higher production rate. Therefore, with an PX120, that might be a good opportunity to start with a container, for example, or a cylinder bundle.
So we have a big roastery with 5 or 6 roasters. You just need a pipeline connection.
Yeah, I guess. That is.
But we can also, I guess, add more cylinder bundles to one package.
You can put it in a row.
Yeah, maybe that. So we can also increase the batch numbers when we have more bundles, of course. I guess these figures underlines maybe the solution that we just have mentioned to get a dual fuel system.
Yes.
So we are able to roast on hydrogen, but we are also able to roast on natural gas. So maybe the customer, when we are talking about the PX120, we can roast almost 36 batches at the end. So maybe on 25 batches or something like that, the customer is able to phone his gas dealer. So bring me one more cylinder bundle,
Yes.
and he's
Put it in a row,
able to switch then to natural gas. And when the bundle arrives, he's able then to switch back to hydrogen.
Yeah.
Yes, that's good. Yeah.
Yeah.
That's possible.
Okay, so I guess we have addressed the topics that we would like to talk about today. So to our customers, to our viewers, so we hope that we have made the topic more clear to you, and we're really looking forward to working with you on future projects. And we from PROBAT, we are fully convinced about or of the technology of hydrogen. And so we have implemented the technology to all of our roasting systems, so including the main burners and of course the heat treatment systems. So we can state we are ready. So we are waiting for your contact. If you are considering to use hydrogen, please get in touch with one of our area sales managers. We can start bringing your roastery in the future. So until then, I would like to refer to the next seat session that takes place on December the 20th. And until then, we wish you a really nice pre-Christmas period. And we say thank you for watching and goodbye.
Thank you. Goodbye.
Thanks and bye.